Hello everybody, we are back with section 5.4 and this is addition and subtraction of polynomials. It's not too difficult and it's actually a relatively short section, okay? So first we have to know what a polynomial is. So a polynomial is a finite sum of monomials. And just a reminder, all of this is in the PDF documents of the notes in the modules as well. Okay, so if you don't want to write all this down and you can't read my handwriting, it is in the PDF documents of notes under modules. All right, so polynomials, the finite sum of monomials. So we have what is called a binomial, right? And if we break the word apart, bi means two. So this means that this has two terms, okay? Two terms. So an example would be something like 3a minus 4c, right? This is the first term. This is the second term. So it's separated by the addition and the subtraction. Okay, so first term, second term. We also use what is called a trinomial, right? Break the word apart. Tri means three. So this is three terms. So an example of this would be 3x squared plus 2x plus 1. Okay, here's our first term, our second term, and our third term all separated with this problem by addition. Okay, so that's all that this is. The test isn't going to ask you if it's a binomial, trinomial, polynomial. They may have a question or two for the homework that ask. Okay, nothing too crazy. But now we're going to talk about the degree. Once again, you'll need to know this for the homework, but not for the test. Okay, so we're dealing with a degree. So the degree of a monomial, or not a monomial, yeah, monomial, sorry. Degree of a monomial is the sum of the exponents of the variables, okay? The degree of a polynomial in one variable is the highest power to which the variable is raised. This will make more sense once I do a couple examples, okay? So a degree, and this is of a monomial, so the first part is for a monomial. Okay, monomial, mono means one. So the degree of a monomial of one term is the sum of the exponents of the variables, okay? Now the degree of a polynomial, right, we dealt with polynomials up here, so when they have multiple terms in one variable is the highest power to which the variable is raised, okay? So let's do some examples so that this makes sense. Okay, so they want to know the degree, and let's say they gave us 3x to the fifth plus 2x cubed plus 1. Well, first let's go ahead and look at this. Is this a binomial, a trinomial? Is it a monomial, right? Monomial meaning one. This one happens to have 1, 2, 3 terms, so this is a trinomial, okay? And we want to know the degree. Well, they said the degree of a polynomial in one variable is the highest power to which the variable is raised. Well, they all have a variable of x, right? They all have, except this one doesn't have an x. These two have the variable of x, right? The one variable. Now, which variable is the largest? Well, right here, this has an exponent of 5. That's the largest exponent. So the degree for this problem is 5. That's it. That's all you got to do. Okay? That's all you have to do. Let's do a degree for another one. Let's look at 2x plus 1. Find the variable. I have an x. I don't have anything else going on. So what's the exponent? Well, if it's just x, it has to be a 1. So the degree for this problem is 1. Okay, that's it. If we were given monomial, 3x to the 5th, our degree is the exponent. It's 5. Okay, that's all. Let's say they gave us -9. Well, does this have a variable? No. So this has a degree of 0 because there is no variable. So it cannot have a degree. There's no variable. Okay? So that's all you need to know about the degrees. So now we're going to be able to add polynomials together and also subtract. Okay? So we're going to be able to add and subtract these polynomials. And it's not too difficult. You just have to remember like terms. Okay? So let's go ahead and look at 2x squared plus 3x plus 4 plus the whole quantity of 5x squared minus 6x minus 3. All right, we're going to be able to add those together. Now, when it's addition, it's nice because adding doesn't change any of that, right? It's not going to change this from addition. It's not going to change that. It's not going to change this, okay? So what's nice here is we can drop the parentheses, okay? We're dropping the parentheses. And then we're going to combine like terms. Now, if you need to reorder the like terms so they're next to each other with the signs, okay, that's fine. Just take the sign with it, all right? So 2x squared, and I also have a 5x squared. So 2x squared, bring the sign. This is a positive 5x squared. Perfect. I have a plus 3x. Let's see if there's another x. I do, here. Bring the negative with it, the subtraction, negative 6x. I have a plus 4. Let's see if I have another number. Oh, I do. Negative 3, minus 3. So just take the signs with it. So now we can group those together and add, okay? They're like terms now. So now I can add the numerical coefficients, the 2 and the 5, to give me 7. Keep the x squared, okay? Here I have 3x minus 6x. Well, 3 minus 6, negative 3, keep the x. And here I have 4 minus 3 plus 1. Okay, that's your final answer for that problem. Let's look at x squared plus 7x plus 4x plus 28. Okay, so this is another example. See if we have any like terms. Do I have another x squared? Nope, so that's fine. Well, let's look next. I have plus 7x plus a 4x. I can combine those. 7 plus 4 gives us an 11. Keep the x. And then I have a plus 28. I don't have any other like terms, so that's your final answer for that one. Okay? So the adding, super easy, nothing too difficult. Just make sure you pay attention to your signs and apply your sign rules that we went over the very beginning of the semester. So let's look at subtraction because this is the one that's a smidge different. So let's go ahead and look at 5x squared plus x. This is a plus 2 minus the whole quantity of x squared plus 3x plus 7. Okay? So the difference with this problem is the subtraction matters, the sign matters, because I'm subtracting this entire polynomial that's in the set of parentheses. I am subtracting all 3 terms. Okay, so you are actually going to be distributing. Remember, we dealt with an imaginary 1 in the beginning of the semester to distribute. You're distributing a -1 to each of those terms. Okay. All right. So now I'm going to bring down my 5x squared plus x plus 2 because that's not changing anything. Okay. Now I'm going to distribute this -1. Well, negative 1 times x squared is negative 1x squared. You don't have to write the 1 unless you want to. Now I have negative 1 times a positive 3x. Well, that's now negative 3x. And I have a negative 1 times a 7, so that's a negative 7. Okay? Now that we've done this, we can start combining like terms. All right? So I'm going to start here. I have a 5x squared. Let's see if I have another x squared. Oh, I do. And it's a negative x squared. Next, I have a plus x. Let's see if I have another x. I do. It's a negative 3x. I have a plus 2. I also have a minus 7. Okay? So now I have them grouped. You don't have to do it this way. It's just if you visually need to do it this way, that's fine. And we're going to go ahead and simplify. So 5x squared minus x squared. So 5 minus 1 gives us 4. Keep the x squared. Okay? Now I have a positive 1x minus 3. So 1 minus 3, negative 2x. Okay? Now I have 2 minus 7. 2 minus 7 is negative 5. So 4x squared minus 2x minus 5 is your final answer for this one. Okay? All right. Let's do another with the subtraction. They may tell you to subtract negative 4x squared minus 3x plus 8 from x squared plus x plus 1. You need to pay attention to the wording. This says to subtract this polynomial from this polynomial, okay? So you are starting out with x squared plus x plus 1 minus the negative 4x squared minus 3x plus 8, okay? It says to subtract this whole polynomial from this one, okay? Now we can go ahead and distribute our negative, okay? So we're going to bring down our x squared plus x plus 1. Now here we're going to distribute a negative times a negative 4x squared. That becomes a positive 4x squared. I have a negative times a negative 3x. Well, that becomes a positive 3x. And now I have a negative times a positive, so that becomes a negative 8, okay? Now we're going to go ahead and rearrange the problem with like terms. Well, I have an x squared. I also have a positive 4x squared. I have a positive x and a positive 3x. I also have a plus 1 and a minus 8. So now I can go ahead and group those together and simplify. So remember, this is a 1 in front of this x squared. So 1 plus 4 gives me a 5x squared, right? We have those like terms. We can add and we keep the x squared. Here I have an x. Remember, there's a 1 there. 1 plus 3, so that becomes plus 4x. Now I have 1 minus 8, so remember from the beginning of the semester, that would be a negative 7. Okay, so that is our final answer. 5x squared plus 4x minus 7. Can't combine those together, okay? Those aren't like terms. All right? The last thing in this section is substitution, okay? So we dealt with substitution before at the beginning of the semester. All right, so they're going to tell you to find the value of 2x squared minus x plus 3 when x is negative 3. So we dealt with substitution before. So we're going to substitute negative 3 in for the variables, right? So we have x's here. Remember, when we did this before, you needed to put in parentheses for the not the exponents, but for the variables, so that you can take into account the negative 3, right? Because it's included, that negative is included. So here we have 2 times, in parentheses, the negative 3 squared, minus, in parentheses, the negative 3, plus here we have our positive 3, okay? Now we can go ahead and simplify. So we did this before. I have a negative 3 squared. The negative's in the parentheses, so you're including it. So this is negative 3 times negative 3, you end up with positive 9, okay? So order of operations, remember PEMDAS, please excuse my dear Aunt Sally, right? Parentheses, exponents, multiplication or division as it occurs from left to right, addition or subtraction as it occurs from left to right. So make sure you're remembering those from the beginning of the semester, right? So order of operations, we couldn't do anything with the parentheses, but we can do the exponents, okay? Here, I still have our minus, negative 3, plus 3, okay? Now we're moving on. I did exponents. Now we're looking at multiplication. So I can multiply 2 times 9 to get 18. Now here, I have a negative and a negative, right? This is like multiplication. Negative 1 times negative 3, positive 3, plus 3. Well, since this is all addition, I can go and add 18, 3, and 3 to end up with 24. Okay, so this is the last thing in this section. Nothing too new, right? You've dealt with this before. Okay, let's just do one more example so you have it. And believe it or not, that's the end of this section. It was a shorter section. So we're going to find the value of 4x squared plus 2x minus 3 when x is a positive 5, okay? So we're going to substitute this 5 in for the x's. Make sure you put in those parentheses so you're performing the right operations in the correct form of the order of operations. Okay, order of operations, can't do anything with the parentheses, so we move on to exponents. So I can do 5 squared. 5 times 5 gives me 25, okay? Now I'm moving on to multiplication or division. I have multiplication going on, so I can do 4 times 25 gives us 100, plus 2 times 5 gives us 10, minus 3. Now, make sure with your adding and subtracting, you do it as it comes, right, from left to right. Do whatever comes first. So that's 100 plus 10 gives us 110, then subtract the 3 to end up with 107, okay? Don't subtract first. You need to go ahead and handle this first, okay? All right, so that is the end of section 4. If you have any questions, please let me know. All right, I'll see you again for section 5. Bye.